Students often get confused with the idea of valence electrons and deciding what are and what aren't valence electrons. So I decided that rather than talk about it, I wanted to talk a bit and then have you solve a problem. So this will be one of our problem videos. Now, valence electrons are going to be, at least in part, the outermost electrons. But there's a bit of nuance to that, especially when we get to transition metals. So when we're counting valence electrons, we're going to count our top n level, and especially with transition metals, this will matter, our top d orbital. Now let me focus in on why. Now this is our electron configuration notation for iron. And you can see here, I'll just help you spot this quickly. If you're looking for where the breaks are and where you would have your condensed notation, whenever you got a p orbital that's full, followed by the next higher s level, that's certainly going to be one of your break points. So you can see here that we'd have our 3p6. We've come back around and we're filling up our 4s2, and then we've got our 3d6. So in this case, we'd have our valence electrons be our 4s and our 3d. So this would have a total of 8 valence electrons right now. You'll also see other times that it's counted differently. Some people really prefer to leave out the d electrons and focus just on s and p electrons. If you've heard of the octet rule, that rule is more connected to the octet rule because your s electrons and your p electrons add up to 8 in octet. If you're not working with the octet rule and you're focused instead on which ones are interacting with their neighbors, which is more what the definition of valence electrons is, then we're going to be able to count the d electrons too. So if you're looking at other resources as well, be aware that there's going to be some difference of opinion on that. And it's not really so much a difference of opinion, it's a difference of application. It's just what kind of way are you using it. Now, without much further ado, let's go ahead and have you solve this problem. I'd like you to write your inner shell electron notation. I'd like you to identify the noble gas that it matches up with. And then I also want you to count the number of valence electrons and write down the number. Go ahead and pause the video and try that now. Okay, so let's take a look. So our inner shell electron notation. So the inner shell is going to be all of these. So we're going to have our 1s2, our 2s2, 2p6, 3s2, and 3p6. All of those are going to be inner shell electrons. Now, we need to know what noble gas it's going to match up with. So we're going to go ahead and look at our periodic table. And on the periodic table, we see iron. Previous noble gas is going to be argon. And so we're going to write argon in the brackets. Okay, so we'll have argon for that configuration. Our valence electrons will be our 4s2 and our 3d6. So if we were to write down our condensed notation for this, it would be argon. We'll have 4s2, 3d6. There we are. And that's going to give us 8 valence electrons in that case, 2 of which are going to be counting toward our octet rule.